Transformations. We'll practice O-level maths past exam paper question about transformation from the series May-June 2024 paper 2-1. Let's begin. So May-June 2024 paper 2 variant 1. And the question about transformation says that triangle A, which is this triangle, is mapped onto triangle P. Now what does that mean? Is mapped onto means is turned into, or better than that, we can say that triangle A is transformed into triangle P, and the transformation is a translation, and the translation vector is 1 minus 3. And we need to draw the triangle P. Now triangle A that is given to us, we need to transform this triangle A into triangle P. And we need to do that by translation, and the translation vector is 1 minus 3. Now in translation, the translation vector has an x value and a y value. The x value indicates movement in x direction, that is movement to the right or to the left. Movement to the right is positive and movement to the left is negative. Now the translation vector that we have, the x value in this translation vector is 1, positive 1. The positive indicates that movement is to the right, and 1 indicates that movement is 1 unit to the right. And in the translation vector, the bottom value is the y value. That indicates movement in the y direction. That means movement upwards or downwards. Upwards movement is positive and downwards movement is negative. In the translation vector that is given to us, the y value is negative 3 or minus 3. Now the minus sign indicates that movement is downwards, and 3 indicates that it is a movement of 3 units. So the x value of this translation vector tells us that the movement is 1 unit to the right, and the y value of this vector tells us that movement is 3 units to the left. Now since this translation is being applied on triangle A, that means every point of triangle A needs to be moved 1 unit to the right and 3 units downwards. This is triangle A, and we need to move every point of this triangle 1 unit to the right and 3 units downwards. Now first let's translate this point 1 unit to the right and 3 units down. If we move it 1 unit to the right, this point will move here, and moving it 3 units downwards takes it here. Now let's translate this point 1 unit to the right and 3 units downwards over here. Then we translate this point 1 unit to the right and 3 units downwards. Now let's join all these points to make a triangle. So the triangle A has been translated 1 unit to the right and 3 units down, and this is triangle P that we needed to draw in the question. The next part says that describe fully the single transformation that maps triangle A onto triangle B. Now we need to describe the transformation that transforms triangle A into triangle B. Now this is triangle A, and it is transformed into this triangle B. And we need to find out which transformation does this job. If you notice, when triangle A is transformed into triangle B, the size gets smaller. So there's a change in size. And out of all the 4 translations that are included in our syllabus, only one produces change in size, and that is enlargement. So this transformation can only be enlargement. And enlargement can make the shapes larger, or it can even make the shapes smaller. So whenever there is a change in size, the transformation is enlargement. And so the transformation that maps triangle A onto triangle B is enlargement, because there is a change in size. Now in enlargement, the first thing that we need to know is the center of enlargement. And to do that, we need to join the corresponding points. Now look at this 90-degree angle here in triangle A, and the 90-degree angle in triangle B is over here. That means this point in triangle A is the same as this point in triangle B. So these two are corresponding points, and we need to join the corresponding points with a straight line. So let's join these 2 points with a straight line. Now look at this point in triangle A, and this point in triangle B. These two are corresponding points. Let's join them together as well with a straight line. And the intersection of the lines joining the corresponding points is this. And this point has an x coordinate and a y coordinate. Now the x coordinate is the value on the x-axis, which is 0, and the y coordinate is the value on the y-axis, which is 1. 0, 1 is the center of enlargement. So we have found out the coordinates of the center of enlargement by joining the corresponding points, and the coordinates are 0, 1. And the next thing that we need to find out in enlargement is the scale factor of the enlargement. And to do that, we need to divide the length of final shape with the length of the initial shape. Now triangle A is transformed into triangle B. That means triangle B is the final shape and triangle A is the initial shape. And this length in triangle B is the same as this length in triangle A. So these two are corresponding lengths in these triangles. And in triangle B, this length is 1 unit long, and in triangle A, this length is 2 units long. Now using the formula length of final shape divided by length of initial shape, the length of final shape is 1 divided by the length of initial shape is 2. 1 divided by 2 is equal to 0.5. That is the scale factor of this enlargement. Now we can use other lengths and apply the same formula to find out the scale factor. For example, this length in triangle B is 2 units long, and its corresponding length in triangle A is this, which is 4 units long. So length of final shape divided by the length of initial shape would be 2 divided by 4, that is equal to 1 divided by 2, and that equals 0.5, which is the scale factor of this enlargement. So we know that the scale factor of this enlargement is 0.5, and so the transformation that maps triangle A onto B is enlargement with the center of enlargement at 0, 1, and the scale factor is 0.5. Let's write it down in the answer space. So the transformation that maps triangle A onto triangle B is enlargement with center 0, 1 and scale factor 0.5 for 3 marks. Now in the next part, the question has given names to two transformations, transformation M and transformation R. Transformation M is a reflection in the line y is equal to -1. Y is equal to -1 is the line of reflection, and transformation M is a reflection in that line. And transformation R is a rotation. The direction and angle of rotation is 90 degrees clockwise, and the center of rotation is the point 1, 1. This is transformation R. Now the question writes the name of those two transformations, transformation R and transformation M, and after that it writes B inside the bracket, and that is equal to Q. Now B that is written inside the brackets is the shape on which the transformation is being applied. This is triangle B or shape B, and transformation is being applied on this shape. So B is the shape or the triangle on which these transformations R and M are being applied, so that is why B is written inside the brackets. And R and M written outside the brackets means that the transformation M and transformation R, both of these are being applied on shape B or triangle B. But we need to know which transformation is being applied first and which transformation is being applied after that. Now immediately to the left of the bracket, M is written. That means the first transformation that is being applied is transformation M, and R is written away from the brackets. That means transformation R is being applied after transformation M. So first transformation M is applied and then transformation R is applied. So the first thing that we need to do is apply transformation M on triangle B. But we know that transformation M is a reflection in the line of y is equal to -1. That means first we need to reflect triangle B in the line y equals -1. So the line of reflection is y equals -1, and the triangle on which this reflection is applied is triangle B. this is y equals -1. And the horizontal line that passes through this point is the line of y is equal to -1. So this is the line of reflection, and we need to reflect triangle B in this line. Now let's first reflect this point in the line. This point is 2 units above the line. So after reflection, this point will be 2 units below the line over here. And this point is also 2 units above the line of reflection. So after reflection, this point will be 2 units below the line of reflection over here. This point is 4 units above the line of reflection. After the reflection, this point will be 4 units below the line of reflection over here. Now let's join all these points to make a triangle, and we have reflected triangle B in the line y equals -1 to get this triangle. And that means we have applied the first transformation M. Let's give a name to the result of this transformation. Let's call it triangle D. So after applying the first transformation M, the result we get is triangle D. Now we need to apply the next transformation R on the result of the previous transformation. That means we need to apply transformation R on triangle D. So next, apply transformation R on the result of the previous transformation. And the result of the previous transformation is triangle D. That means apply transformation R on triangle D. But we know that transformation R is a rotation, a 90-degree clockwise rotation about the point 1, 1. And that means we need to rotate triangle D 90 degrees clockwise about the point 1, 1. Now this is triangle D, and we need to rotate this triangle 90 degrees clockwise about the point 1, 1, which is the center of rotation. So this is our center of rotation, and let's say we need to rotate this point 90 degrees clockwise. So the first thing that we need to do is join the point that we need to rotate with the center of rotation. So we are going to join the point that we need to rotate with the center of rotation, like this. Now we need to rotate it 90 degrees clockwise. That means 90 degrees in this direction. Now you can use a protractor to draw a line that makes a 90-degree angle over here, and that means this point has been rotated 90 degrees clockwise. Now to find the location of the rotated point, we need to use a compass. Open the compass to this length, the distance between the point that we are rotating and the center of rotation, and place the compass on the center of rotation. Then draw an arc. The intersection point of the arc and this line is the location of the point after being rotated 90 degrees clockwise, and that is over here. Now let's rotate this point 90 degrees clockwise. First we need to join it with the center of rotation using a straight line. And after that, draw a line that makes a 90 degrees angle over here, and this means that this point has been rotated 90 degrees clockwise. Now to find the location of the rotated point, place a compass over here and open the compass to this length, the distance between the point that we are rotating and the center of rotation, and draw an arc. The intersection of the arc and this line will be the location of the rotated point, that is over here. Now let's rotate this third point about the center of rotation. First we need to join the point that we are rotating and the center of rotation. Next, use a protractor to draw a line that makes a 90 degrees angle over here. That means we have rotated it 90 degrees clockwise. To find the location of the rotated point, place a compass over here, open the compass to this length, and draw an arc. The intersection point of the arc and the line will be the location of the rotated point, that is over here. And this is the triangle that we get after the rotation. So triangle B has been transformed into triangle Q by applying two transformations. First the transformation M, and second the transformation R. And so we get the triangle Q. And this is exactly what we had to do. Draw triangle Q for 3 marks.